Hi, this is Mrs. Kinman, and in this video, we are going to be discussing how we can evaluate trig functions using the unit circle. So when it comes to using our unit circle to evaluate trig functions, we can actually, that's one of the greatest uses of our unit circle, is we can use it to figure out what different values are in our trig functions. So the way we can do that is what actually happens is with our unit circle, we end up creating these right triangles here with the origin of the circle, the radius of the circle being 1 in the unit circle, and our x and y values here creating this right triangle. So in this case, we have a hypotenuse of 1, we have a height of 1/2, and we have a width of √3/2. Okay, so that's kind of how we can line up our right triangle there. Now, if we're talking about the sine, cosine, and tangent of this triangle, what we're looking at here is we're actually going to compare it to this inside angle here that is created with the radius of the circle, the initial side, and the interior angle that's formed at the center of our circle. So when we're looking at that, if we're trying to calculate the sine of that angle here, sine, remember, is going to be opposite over hypotenuse. So what we want to do is we want to take our opposite side, which is 1/2, and put it over our hypotenuse, which is 1. Well, 1/2 divided by 1 is just 1/2. When it comes to our cosine, we're going to take our adjacent side over our hypotenuse. So in this case, our adjacent side is this √3/2 divided by 1 is still going to give us √3/2. And then lastly, we have our tangent. Now our tangent's going to be our opposite over our hypotenuse. So or not over our hypotenuse, our opposite over our adjacent side. So what we want to do here is set this up as the opposite, which is 1/2, divided by our adjacent side. Now this is a little bit more complicated than that other math, so I'm going to write it in another form. We've got 1/2 divided by √3/2. Now when we divide √3/2, or divide any fraction, what we can do is we can actually change, and then flip our fraction over. And what that does is it actually allows us to multiply them straight across. And we get 2 over 2√3, which is the same thing as 1 over the square root of 3. And if we multiply both the top and bottom by the square root of 3, we end up getting that our solution here is √3/3. Now, as we're looking at this, what I want you to notice is the relationship between our unit circle and these values. When it comes to our unit circle, our y value here is the same as our sine. So when it comes to the form of the unit circle, our sine of an angle is actually going to be the y value that we see on the coordinate of our unit circle. Our cosine corresponds directly with our x value, and so that is going to be built this way. So cosine is x, sine is y. Now tangent we know is opposite over adjacent. Now how does that relate to our x and y value? Well, you can see our opposite side here is the same as our y side. Our adjacent side was the same as x. So the tangent is actually going to be y divided by x, or the tangent is sine divided by cosine. And we can actually see that as we go on to compare that idea. If sine is the same as opposite over hypotenuse, and cosine is the same as adjacent over hypotenuse, then tangent, we're told, is opposite over adjacent. Well, if we take the opposite over the hypotenuse and we divide it by, or put it over the adjacent over the hypotenuse, when we do this, we end up getting the opposite over the hypotenuse times the hypotenuse over the adjacent, or opposite times hypotenuse over hypotenuse times adjacent. Well, those hypotenuse can simplify on top, and we get opposite over adjacent. So that kind of proves to us that sine over cosine is the same as tangent. So we can use these different values here to figure that out and figure out these things. Now you can see that all of this mathematics here can kind of complicate things. So when it comes to using our unit circle, we know a couple of important things. We know that the cosine is going to be all of our x values. We know if they ask us for the sine of an angle measurement, we're looking for the y value. Now, when it comes to finding the tangent, we can do that math over and over again. But rather than having to do it over and over, let's just add that math straight into our problem here. So let's take a look at this problem here. If we were to do y over x here, we would get 0/1, which is equal to 0. If we do y over x of this one, we get 1/2 over √3/2. which after we did that complicated math on the previous page, we end up getting root 3 over 3, not over 2. We end up getting root 3 over 3. Now, in this case, we end up with root 2 over 2 divided by root 2 over 2. And anything divided by itself is just 1. And then we have this 1/2 and our root 3 over 2. So here we get root 3 over 2 divided by 1/2. Well, if we do that complicated math there, we end up with root 3 over 2 times 2 over 1, which just ends up giving us the square root of 3. Now, our last one here is going to be 1 over 0, which is actually undefined because we do not have a definition for what happens when we divide by 0. Now, the beautiful thing about the unit circle, as we know, is that there's a lot of patterns, especially based on the reference angles that are created. We notice that if angles have the same reference angle, the coordinates are the same. Now, if the coordinates are the same, the only difference between our x and y values is the signs. So that means that the tangent values are actually going to be the same as well. So what we want to do here is we want to use this pattern to figure it out. So now we have a negative and a positive, which is a negative, but we get the negative root of 3. We've got a negative and a positive here, which will give us a -1. This one will be a negative root 3 over 3, and this one will be a -0, which is still just 0. Now our next boxes, they're going to follow that same pattern, so we're going to mirror it. This will still be a root 3 over 3, but a negative divided by a negative is a positive. So we get a positive, +1, we get a positive root 3, and here undefined is still going to be undefined. Now in our last quadrant here, as we're trying to figure this out, we've got a positive and a negative, which means our result's going to be negative, but it's going to follow the same sign as the one diagonal from it, like this, or as the one that has the same reference angle. So in this case, it's going to be negative root 3. This one is going to be -1, and this one will end up giving us a negative root 3 over 3. Now notice how those ones directly across from each other actually have the same tangent value. So it's pretty cool, all the patterns that we see, but we can use this to figure out what those different values are. So now using our unit circle in its full glory, let's go ahead and evaluate some trig functions using this unit circle here. So if we wanted to figure out what the sine of 30 degrees is, we would go to our unit circle, find 30 degrees, look for the y value, and we end up getting 1/2. The sine of 210, we do the same thing. We go to 210, we look for the y value, and in this case, we end up getting -1/2. For the cosine of 330, we would go to our unit circle, find 330, we want the x value, so in this case, we end up getting square root of 3 over 2. Now, what about if we have a negative value? Well, we talked about coterminal angles previously, which are angles that are all located in the same place. Now, if it's -30 and we add 360, that coterminal angle is going to be in the same location on our unit circle. So that's what we want to do. The cosine of -30 is the exact same place as the cosine of 330 degrees. So that x value is going to be in the same place. We just have gone around our unit circle one more time. So if we look for the cosine of 330, we're going to end up getting root 3 over 2. Now the tangent of 180, remember tangent is y over x, or we can look at our value that we've added and we can see that it's going to be 0. The tangent at 270, as we look on our table here, is going to be undefined. Going back up to the top here, the sine of -135, we can add that 360 to it to find that coterminal angle. And that's the same thing as the sine of 225. And the sine at 225 is negative root 2 over 2. The sine at 90 degrees is going to be 1. And then lastly, our tangent at 300 degrees, if we go back to our unit circle here and find 300, our tangent is going to be negative root 3. So that's how we can use that unit circle to evaluate those different trig functions. It's a fantastic resource, and it saves us lots of time of typing things into our calculator and also gives us more precise answers. If you have any questions, don't hesitate to reach out, but that's how we can evaluate trig functions using the unit circle.